Welcome to clickmyprojects.com. Here we discuss about persistent target tracking using likelihood fusion in wide area and full motion video sequences. This is the flow diagram of our project. In the first step, we give the input video, and from that frame we extract the selected frame and select the region which we want to track the person. Then from that selected values, we extract the feature values from the selected region, and then we extract the features for each and every frames. Then these target features and the features of the each and every frames are given to classifier to classify the values which are matching for frames equal to that given selected target. Then from this, the matching feature values, we suppress the background from the each and every frames, and finally we track the moving object which are selected as a target. Then the final target result is given. The feature values for each and every frames is updated for the same timing of frames incrementation. Thus we track the selected image by using the likelihood fusion method. Video tracking is the process of locating a moving object over time using a camera. It has a variety of uses, some of which are human-computer interaction, security and surveillance, video communication and compression, augmented relative, traffic control, medical imaging and video editing. Video tracking can be time-consuming process due to the amount of data that is contained in video. Adding feature of the complexity is the possible need to use object recognition techniques for tracking. Tracking is to associate target object in consecutive feature frames. The association can be especially difficult when the objects are moving fast relative to the framework. Another situation that increases the complexity of the problem is when the tracking object changes orientation over time. For this situation, video tracking system usually employ a motion model which describes how the image of the target might changes for different possible motions of the object. To perform video tracking, an algorithm analyzes sequential video frames and output the movement of targets between the frames. There are a variety of algorithms, each have strengths and weaknesses. Consider the intended uses important when choosing which algorithm to use. There are two major components of an visual tracking system. One is target representation and localization, as well as filtering and data association. Target representation and localization is mostly a bottom-up process. These methods give a variety of tools for identifying the moving object. Location and target tracking was successfully is dependent on the algorithm. For example, using blob tracking is useful for identifying human movement because of a person's profile changes dynamically. There are some common target representation and localization algorithms. One is blob tracking, next kernel-based tracking, and then counter tracking, and then visual feature matching. In the blob tracking method, it segments the object moving from each and every frames and extract the blobs for the moving objects. Thus it detects the moving object. In kernel-based tracking method, it extracts the mean shifting of frames for the moving object. In the counter tracking method, it detects the boundary of the object moving. Finally, in the visual feature matching, it extracts the feature values for the each and every frames and it registers these frame values. By using matching feature values, we extract the recognized images. In our tracking method, we using likelihood of feature tracking system. In this process, we extract the feature values for the selected object which we have to track. Then we compare the feature values for each and every front, which are the matching values for the selected image. Then finally, we track the moving object by representing a rectangular box on the each and every frame. Now I am going to explain the running process of our project. Now just run video.tm file. Here I create a guide creation for our project. In the first step, we insert the video by clicking insert video button. We can play the inserted video by clicking play button. It creates the guide creation for the multimedia player in the MATLAB. We can play the inserted video. Next we convert the each and every frames into an image by clicking convert button. Here it just converts the videos into frames. Now by clicking background extraction, we extract the background subtraction. These are the binary values which are representing the moving objects. Now tracking the moving objects by clicking track button. The bounding boxes provides the tracking of moving objects. Now we track the selected person by clicking track button. Here I select the car. It extracts the feature values for each and every frames from the selected image. Then the rectangular box follows the feature values which are matching to the selected points. These feature values are extracted for each and every frames, and finally the tracking output which represents the moving object which are matching to the selected target. Here the rectangular box perfectly tracking the moving objects. This is the result for our likelihood feature extraction based video tracking. Thus we track the moving object by using selected feature points. Thank you.